Alright, if you're watching this video, it means you're kind of stuck on stoichiometry. We're going to try and get you unstuck, but I want to make sure that you understand that the factor label method, that one line of things, is optional. So if it's not working out for you, I appreciate that you give it an honest try and you're trying to get it, but if it doesn't work after this, we can keep trying, but what's more important is that you can actually do stoichiometry. Whether you can do it in this method is less important. Anyhow, let's get it started. We're going to kind of do the same thing we did in class. We're going to think about the math, because the math of stoichiometry really is not hard. It looks hard because it's unfamiliar stuff, but the skills are actually pretty simple and straightforward. So let's start with some things that we really know well. If I asked you to convert 5 minutes into seconds, you could do that. And you probably wouldn't write it down like this, but I want you to think about it like this. What you do is you take 5 minutes and then you multiply it by some conversion factor that converts from minutes to seconds. And we have it right there. And looking at the units, the minutes cancel out, leaving me with just seconds. And of course, 300 seconds. Now that's something that you wouldn't have had to write down, but if you did, this is how it would be done. If we change it up a little bit, and I ask you to convert 5 seconds into minutes, oh, that's a little bit different. You would actually end up using the same conversion factor. The thing that 1 minute is 60 seconds. 60 seconds is 1 minute. The direction that I think about it kind of depends on what's more convenient. But now, what I do is I take my 5 seconds and I multiply it by the same thing. Well, 1 minute is 60 seconds, but now I'm going to be doing a division. 60 seconds is on the bottom, 1 minute's on the top, and I end up with quite a small number, 0.083 minutes. Not the most useful thing for me to have, but I can do the conversion. And again, the seconds cancel out, leaving me with just minutes as units. And again, I might not need that for talking about minutes and seconds, but mathematically, that's what happens. If we move from time into weight, well, a 200-pound person, if we want to convert that into the metric, into kilograms, we would need to know how many pounds are in a kilogram. So if I told you that 1 kilogram is 2.205 pounds, you would then use that conversion factor. And again, you'll see that 1 kilogram and 2.205 pounds, those are effectively multiplying by 1 because they are the same thing. 1 kilogram is the same as 2.205 pounds. And you would get pounds canceling out and left with 90.7 kilograms. But if you looked up and had a different conversion factor, if you found out that 1 pound was 453 grams, or 453.6 grams, now it's a bit different, but not much. 200 pounds, that's what I'm starting with. I need to convert that using my conversion factor that I have. Well, 453.6 grams is the same thing as 1 pound. Pounds cancel out. Next, though, I'm going to have to convert from grams to kilograms. So 1 kilogram is the same thing as 1,000 grams. Now again, if I'm careful and I look at my units, where are we? Oh, there we go. Pounds cancel with pounds, grams cancel with grams. All that I'm left with is kilograms. So my units all cancel out, leaving me with 1 unit, and that's the one I want. All right, taking exactly the same kind of ideas into chemistry. And again, we're going to start small, we're going to build it up. Same kind of stuff we did. If I asked you to convert from 3.6 grams into moles, I'm converting from mass to moles. Now we know how to do that. We have a separate formula for that. But if we think about it like this, using conversion factors, what we're doing there is this kind of thing. So I know that the molar mass of potassium hydroxide, KOH, is 56 grams per mole. What that means is 1 mole has a mass of 56 grams. Or if I had 56 grams, well, that's 1 mole. So if I were to write this out as that minutes to seconds and seconds to minute and pounds to kilograms thing, if I write it out with thinking it in terms of conversion factors, I end up with this, that the connection between moles and grams is 56. 1 mole is 56 grams, 56 grams is 1 mole. The grams will cancel out, leaving me with, oh, I did it again, leaving me with just plain old moles. Okay, throw in another one. If I'm converting moles to mass, we know that mass is number of moles times molar mass. But if I treat the molar mass as a conversion factor, then what I'll end up with is my number of moles multiplied by that conversion factor. 78 grams is 1 mole. I'm effectively multiplying by 1. Now that hopefully looks a little bit more familiar to what we've been doing before of mass, number of moles times molar mass though. Again, if I look at my units, moles cancel with moles, leave me with just grams. Can I convert moles to moles? Well, sure I can, if I know how they're related. So I need a reaction. And there's my reaction. And if the question is how many moles of aluminum hydroxide are made from 4.6 moles of potassium hydroxide? Well, now I know that in the balanced chemical reaction, every time I use 3 potassium hydroxides, I get 1 aluminum hydroxide. So that's my conversion factor. Which one do I put on top? Well, which one am I trying to get rid of? I'm starting out with moles of potassium hydroxide, so I want that to cancel out. So now it starts on the top, I need to put it on the bottom. And I end up with 1.53 moles of aluminum hydroxide. I probably should have had the label on there. Okay. Now, before, what we did was we set it up like some sort of ratio. We had our balanced chemical reaction, asked the same question, and we looked at it in this kind of ratio. And that works. There's still no problem with that one. But what I want you to do is I want you to think about how you would have solved that. Well, I take the thing I want to solve for x. So right now it's x divided by 4.6. So I have to multiply both sides by 4.6. So it's 4.6 times the fraction that's already there. Hey, look, it's the same thing I had on the previous bit. Moles cancel with moles, leave me with moles of aluminum hydroxide. So it's really no different. It's written a little differently, but it's not different math. All right, let's dump all that stuff together into one question. We have a reaction, and we're getting kind of tired of that reaction because we see it a lot. The question is now, what mass can be made from 12.8 grams of potassium hydroxide? And what we're going to do is we're going to take the mass, convert it to moles. So mass of potassium hydroxide, how many moles of potassium hydroxide? We're going to convert from moles of potassium hydroxide to moles of aluminum hydroxide. And then finally we're going to take moles of aluminum hydroxide and turn that into mass. It's going to look like this, but break it down step by step. It's actually stuff that we did in the previous few minutes. So our grams of potassium hydroxide cancel with grams of potassium hydroxide. One on the top, one on the bottom. If they're both on the top, they can't cancel. If they're both on the bottom, they can't cancel. One on the top, one on the bottom. Then moles of potassium hydroxide will cancel with moles of potassium hydroxide on the bottom. One on the top, one on the bottom. But I got that because that's my conversion factor from moles of potassium hydroxide to moles of aluminum hydroxide. And finally, I want mass. So I need to convert from moles of aluminum hydroxide to mass, grams of aluminum hydroxide. Grams goes on top, moles on the bottom, and that's my molar mass part. Moles of aluminum hydroxide cancel with moles of aluminum hydroxide to give me grams of aluminum hydroxide. Solving all that, I get 5.94 grams of aluminum hydroxide. Question answered. If it still doesn't work after this, if you're still not happy with it, feel free to do stoichiometry in a slightly different method. If the way we started out doing it doesn't really work, I can try showing you a different one. This is the one that seems to be what most, let's say, universities, most colleges, most people doing this stuff use. there are other options. What's most important is at the end of the day, you can do stoichiometry. It doesn't have to look like this, but you need to be able to do stoichiometry. Hope it helped. Talk to you in class.